With too much data, you can lose sight of the forest for the trees. Well, my next guest revolutionized the ability of the U.S. Forest Service to visualize as useful information the massive data from aerial surveillance. For his work, he's a finalist in this year's Service to America Medals program. Research forester Robert McGoy joins me now. Mr. McGoy, good to have you with us.
Thank you, Tom. Nice to be here.
And you are a programmer of software code that did something to other software to make it usable. Tell us what you've done here.
So technically, I'm trained as a forester, so it's an interesting combination being a programmer and a forester. But the technology that I work with is called airborne LiDAR. That's light detection and ranging. And the basic idea is you have this laser rangefinder in an aircraft that fires out millions of pulses per second or a million pulses per second, gets a measurement of every object that pulse hits, and naturally produces a lot of data. So the software that I've developed reduces that data down to more usable products. The software has been around for about 20 years and been used across the country within federal agencies, universities especially, and then around the world as well.
Interesting. So the LiDAR is then surveillance that is not photography. It's surveillance using this LiDAR. And what is the output of LiDAR in its raw form?
The true raw form are just range measurements from an aircraft. So the distance to an object that's hit by that laser pulse. That's combined with the position and attitude of the aircraft to get an actual XYZ point for every object that's hit. And as I said, it's millions of points over a small area, densities in the 10 points per square meter and higher.
So in other words, it's a way of representing as data a potentially three-dimensional image of what you're looking down at with the LiDAR equipment.
Exactly. That's it.
And so the output of putting the LiDAR data through your program, does that result in pictures or visualizations?
Visualization is a big part of it. Just understanding what these systems measure. It's kind of hard to wrap our brains around the complexity that happens, with this laser and the distance and the precise attitude and everything. But just knowing that it hits trees, buildings, the ground especially is important. But we reduce that down to something that's more usable. Just a whole bunch of points. It's interesting to look at. But from an information standpoint, our brain processes things really well, and we can see patterns and see objects that we recognize. But getting our computer to see that is a little different.
So how does this work in a practical sense for the Forest Service? First of all, we'll talk about that context that you developed it for in the first place.
So for us, it was really a research problem to start with, to understand if these systems were even useful for forestry. We knew that they could measure the ground really well, very accurately, but we didn't even know if we would get data from trees. So once we realized that we could get good measurements from trees, we could measure the tree height over very large areas. We can measure variability in that height. We can measure patterns of vegetation. So there are trees in some areas, not trees in others, big trees, little trees. And all of that information is useful for making management decisions. It starts to give us information about the size of the trees, potential value, something about the age just because of their size, where there are denser areas of trees that might need to be thinned to encourage growth or to remove or reduce fuel for fire risk. Things where we might want to go in and plant because there's not enough trees. So all those kind of things are useful information to have over large areas, and it's wall to wall over the areas covered by this data.
I suppose it could also tell you reasons to look into further as to why the forest density is higher here as opposed to there also.
It could give you some indication. At least it would tell you the areas where you have conditions that maybe you want to know more about. So kind of a reconnaissance before you were to go to the field to do more work.
We're speaking with Robert McGoy. He's a research forester with the U.S. Forest Service and a finalist in this year's Service to America Medals program. Okay, so we understand what's happening here from the forestry standpoint. For our programming listeners, then, what did you do to convert the point data from the LiDAR into these visualizations or information that's usable?
So this software, which is called Fusion, because it fuses different sources of data to help you understand what they all measure. As I said, there is a visualization component that just lets you grab small samples of these data and spin them around and look at these point clouds. Really useful for just understanding what's being measured. But probably most useful, there's a whole suite of programming tools or smaller components that allow you to string together commands to take this point cloud and reduce it down to information in a raster form. So that's like little cells of information that have been summarized from the point data. Much smaller, much easier to work with. Typically in a geographic information system, that data becomes very useful and very digestible to other types of software. So the software that I've developed really takes that raw XYZ point cloud or three-dimensional point cloud and boils that down into something that's much more usable for a broader audience.
Well, how did people use LiDAR data before this?
I started developing software pretty much about the same time LiDAR came to forestry. So in the late 90s, there were some initial research efforts to understand what the technology could do. I like to joke our first project included 40 million data points, and we had no software. There was nothing commercially available that really could handle 40 million points. Today, that's collected in a blink of an eye. I mean, literally, we collect 40 million points in a few seconds.
Right. When the first hard drives came out for PCs in that era, you had to decide, should I get the 5 megabyte drive or the 10 megabyte drive?
Yes, things have come a long way. Yeah, we just keep adding zeros to the end of those numbers, and we seem to add them pretty quickly.
And as a forester, I mean, you were trained as a forester. That was your career choice. How did you bridge from looking at trees as a forester to looking at trees as a programmer?
So my undergraduate work was in forestry, and I did a master's in forestry, but I developed software for my master's work as well. My original work was in timber harvesting. It was in doing the engineering design behind some of the systems used out west. It's one of those things, computer programming, took a couple classes. I had an aptitude for it, and I actually really enjoyed it. I always see it as kind of the ultimate engineering thing where you're building something that accomplishes a task. So a lot of self-taught.
Sure.
Most of the software that I develop is developed in C++.
Yeah, that was my question, because when you started, I mean, people were still programming point and coordinate data using Fortran and languages of that era.
Yes, that's true. That's true. I actually did some Fortran work at one point, but pretty much self-taught on C and C++. I haven't probably advanced as far as I, could have in that realm, but my software works. It's very robust. I've had the good fortune of having a partnership with a group in the Forest Service that develops training materials. And so we get a lot of testing and training done through the support from that group as well.
Sure. And now Fusion is in the open source world. How else have people applied it that you're aware of?
So open source is a sticky word today because it implies certain things. It's freely available software. It's not really developed as an open source project where we have multiple contributors, but it's been picked up. The software is distributed as executables. The code is available, but it's been picked up in academia to a large extent and used to help teach students what you can do with LiDAR data. And I see that as one of the most valuable things. It's just we've had a whole set of students go through academia that now know about LiDAR and how to apply it to natural resource things. It's used internationally. If you do a survey of the literature, you find, I would say, maybe 1 in 4 papers have used the Fusion software to do some of the point cloud processing, partly because it's free, so people can download it and use it. And it really is designed from a forestry perspective rather than a remote sensing or engineering perspective. So some of the products and the way that it does things and kind of the terminology and everything are friendly to foresters. So that's really helped it be picked up and used around the world.
And are you still working on it? Do you still work to perfect it?
I am still working on it, yes. There's actually a release that'll come out here in the next week or two that incorporates a new point cloud format for the data. Probably do 2 to 3 updates a year or major updates. I haven't really added a lot of new capability for a few years, but we continue to kind of work on how to chew through lots of data faster. These data sets, as I said, are huge. Billions of points, literally, consuming pretty large space on disk drives and that kind of thing. So there's a real focus now on moving things into the cloud and processing that way.
You've moved from the Fortran world to the Drupal and Kubernetes world of large data sets in the cloud.
At least as far as large data sets, the software doesn't really deal with things in the cloud. It's really set up for desktop use. It's all Windows based, partly because that's what the Forest Service uses for its computing systems.